We're going to start by creating a Sci-Fi city function, which we're going to do within the terrain editor. So what I want to do is add in a procedural terrain, and go ahead, you can double click on it. If that doesn't work, to open up the terrain editor, you can right click and go to Edit Object, or go up to Object and Edit Object. So in the Procedural tab, we can see the current procedural. I'm going to start by turning off the Zero Edges mode on the terrain, and we can see that current function. I'm going to go ahead, right click on the function and edit the function. Now, because the values of the seed node that are added to the vector could possibly change if we save out the terrain as a preset and reload it, I do want to just define these values manually, which we can do by creating a math node of an offset. I'm just going to select that and delete it. Now, because of the dimensions that I have to record at, you can see that most of the function editor is going to be hidden. I am going to have to just kind of move things out of the way. What I do have open right now is the node preview and the output observer. The node preview is going to be really important for monitoring the numeric values of the output so that we can keep things within the range of 1 to -1, which will be pretty simple for the most part directly from the nodes, because we are going to be using mostly noise nodes. Also, in my interface, I have show parameter connections turned on, and what that's going to do is, if I zoom in, we can see all these connections on the sides of the nodes, and those are linked to the parameters within that node. So having that turned on is really helpful. So I also want to set up a slight change of the previews of the nodes. So what we can do is go up here to the upper left, select Preview Options, and I'm going to change the objects to be displayed over to the 2D plane. The reason for this is the terrain is only a slice of the space that we're working with in the fractal, and then that value is extruded in order to create the elevation. So that basically makes the 3D previews not very helpful. They're not going to show us as much. Now, there is an exception to that if you're using view 7 or higher and you have a planetary terrain. Or it might be view 7.5 and higher. The spherical terrains, spherical scenes, those will use the x vector, or sorry, the z vector, which is the up and down vector. Almost basically regardless of your settings within the options. I'm just going to close this out really quick, and if you go to File and Options, a couple of other things I just want to mention. One is that under the units and coordinates, I do have one view unit equals 1 meter. View 5 and 6 users don't need to worry about this. View 7, you may have to change it to 0.1 meters to equal the exact amounts that I'm going to be using within the functions. And view 8 users and higher can set this to 1 meter to get all of the outputs that I'm getting. But what we can also see under the world coordinate system, I do have the z-axis up. And most of the functions really rely on having the z-axis up, regardless of this setting. So we're going to keep the z-axis up. Go back and edit that object, go into the function, and we can either switch this fractal over to a noise. We can, with it selected, go over to the left where the Replace by Noise or the Noise node button is, and add in the noise node to replace it. Or you can add it in manually and then make a connection from the altitude to that noise. If you are unfamiliar with the basics of the function editor, What we have are the inputs on top. Within the terrain editor, the options are very minimal. We basically have position and time. If you right-click, we can take a look at the list of input nodes. Now, a lot of these aren't going to work within the terrain editor, as well as they would work within the material editor. So the main ones we're going to look at using position and possibly the position options, which will give us the ability to change units using a standard unit or using a spherical parametric in different modes. I'm going to be mostly working in the object parametric mode to make creating the materials a little bit easier once we get to that point. So the way that the functions work, we start from an output. That outputs a value. In this case, we have position, which is a red line representing a vector. The vector is, as we saw before, the XYZ for that offset. To break that down, we can right-click, add a math node, vector operations, use the decomposer 3. And then I'm going to add in another math node, vector operations composer 3. And this will allow us to actually break down the individual input, where we can select the XYZ. And now we have blue connections, which represent a numeric value. So the red connection is a vector, which has 3 numeric values representing the x, y, and z. Within the terrain editor, the z is really only used to scale or adjust origins, and excluding, of course, planetary terrains, which will use that z in order to create the geometry. But right now we basically just have the x and y, which are the primary controls. The z is important for creating an offset of the node. But other than that, so if we go to the origin and type that in, it will modify that. But besides that, the z is pretty much not going to have a huge influence. You can see we can modify that scale really large, and we're really not going to notice a difference or a change, at least not with this type of node. The output will change within the node preview, but it's not really going to modify anything. The origin is what is going to change. So this sends the vector data to any sort of control node. This is a noise, which is a very simplistic type of pattern. It then uses the position data to find out where it is, where the node is, and then creates a numeric output which connects to the altitude. And if you're using version 7 and higher, you can also add additional outputs as custom dependencies. These can be accessed within the material editor or graphs, object graphs throughout the scene to be able to directly link to anything you've created within these functions. We'll take a look at those a little later. So this noise, we can also switch over to a fractal. And if we do that, what it's going to do is take the values from the noise and create the fractal version of it. So if we were to change these settings over to a terrain Perlin noise, then click off to get that red box and add a fractal, it's just going to create a simple fractal in this case. Sometimes it will switch it over. It might be the other way around. If I create a terrain Perlin noise within the simple fractal and then add a noise, then you can see it is duplicated. So it does work the other way. Whatever you have as a fractal, then you can output as a noise, which is basically just a really more simplistic version of the fractal. So if we connect to the fractal and look at it, you can see a lot more detail. The fractal is going to repeat a roughness value. There are a lot of different settings available for a fractal. We can see the roughness, a gain amount, smallest and largest features, and those are not going to be available within the noise. Now I also want to mention that the unit system will differ, and these are basically matched up. What I can do is I'm just going to remove that other noise. We just have the terrain noise and then also the fractal variation. Add in, by selecting the link, you can then choose a compatible node, and it does have to be compatible with that type of link. There are limits. The blender or the combiner node, by default it will choose a blender node, is compatible with basically every connection, so whether it's a vector or a numeric value. And the purple lines you'll see when you're working with texture maps are the texture coordinates. So if I connect this blender and I'm going to go ahead and select the link and delete, we have two different inputs for a blender, input 0 and input 1. And then a ratio that will control between the two. You'll also notice that fractals have two different outputs from version 7 and up. View 6 users, it will just automatically connect. Same thing with View 5 users. It'll automatically connect to the altitude. An additional value was added of rough areas, although the rough area output is only available through a couple of different fractals. Basically the terrain fractal or a simple fractal using the terrain Perlin noise. Also the grainy fractal, but that's for View 7 and up. So you can see that we do have a match for the most part here, except for the roughness values. Now the ratio from 0 to 1 goes from input 0 to input 1. So it's pretty straightforward. You can also control that ratio with additional nodes and connections. So we could even connect this to another fractal, change that to a different pattern, and then it will adjust between those by using the control of another fractal. Now if these values go outside of the range of 0 to 1, which in this case they do, they go far below -1, as you can see within the node preview. It will start to extend far beyond the settings of the noise. So you have a clip ratio 0 to 1 that was added in, I believe in version 8. It might have been in version 7. I just really quick opened up the function editor in version 6, and you can see that that is not available. So if you're using version 5 or 6, possibly 7, depending on when that was added in, that ratio connection does not have a clipping checkbox, so it does need to be approached differently. So what you can do is, if you're using version 5 or 6, you can select this connection and then add in filter node, select map, and then you can set your lower value to 0, upper 1, and then the input range -1 to 1, unless you want to balance that out to grab from the entire fractal. You can fine-tune the adjustments and pay attention to the node preview to see what your outputs are. But what this is doing is condensing the information from -1 to 1. So basically a numeric value of 2 to 0 to 1. And then you can clip the out-of-range values. And that'll make sure that anything that goes beyond 1 or lower than 0 is going to be clipped out. So there are ways to really easily do that within version 5 and 6. To get a perfect match to what that clip ratio 0 to 1 does, you will need to set the lower value possibly to 0, because it is clipping it out automatically at 0, and we don't have an adjustment automatically within the blender to clip the ratio or reduce it and fit it. So for an exact match of that feature, for 5 and 6 users, use the map node or map filter 0101, clip the out of range values. There are other nodes available as well that will also provide this. You can also use the clip node, but that provides a contrast and brightness, and it will modify things overall. There's a lot of different ways we could really set that up. You could also set a floor and a ceiling amount, which will set the minimum amount, clip anything below 0, but let 1 or anything above 1 continue. If we also add in a ceiling, you could set that to 1 and clip anything out that goes above 1. These are also going to be really useful for cutting these out in any version. So not just 5 and 6 users. We'll also be using these in version 8.5, which is what I'm using right now. But the way we're creating this and controlling these functions have been around for a while. We're going to be taking a look at a lot of the newer features that are available to version 7 and higher users. Also some of the more unique features to version 8. But for the most part, this will be able to be performed within just about every version of Vue since version 5. So do a little cleanup here. Delete those fractals and just work with this noise and change around our connections. And you can grab from that line just underneath a node. And once you have it selected, it'll highlight and show little circles around any compatible node it can be connected to. And then you just make sure that you drop, or when you let go from the mouse and unclick the button, that is within that range or within that circle. Because if it's not, it may not connect, depending on which version you're in. Version 5, 6, and 7, I know that if you weren't within that circle, it probably won't connect, also depending on how far you're zoomed in. So you might just need to make sure that you're within that circle. Version 8 and higher, usually just being over the node, it will automatically connect. So I am going to keep this decomposer and composer node within the vector sequence in order to be able to use numeric filters that aren't available for modifying vectors. And we can do that per individual connection. There's another vector node I'm going to be adding in. We're going to connect the noise to the composer 3. And I want to add in something to make this a little bit easier to manage the vector of all of the noises we're going to have. Because by default, what's going to happen is every noise we add in, any fractal, it's going to automatically connect to that top position. So if we have a function with, let's say, 12 noise nodes, and we want to modify the vector of all of them, then we're going to have to go through and connect all of those to a single link. And just to make things easier as we're going, we're just going to do that. Keep it a little cleaner, a little more efficient. So we'll add in a math node, and we're going to change this over to the vector operations offset. And I'm going to set the z to 0. By default, it will have 0, 0, 1. So we'll add that to our chain. And now this next node I want to add in, what we can do is select the vector. And anytime you have a node selected and you go to create the same type of node from the left menu, it will automatically duplicate that type of node and also the same settings. So since this is compatible with the vector, we select the math node offset, select that vector, and we can add in a math node. And it's going to automatically create that same offset without that default 1 because it is duplicating those settings. Now we're not going to use an offset. We're going to switch this over and change it to the matrix transformation, which allows us to modify the values of the vector matrix a little bit easier. It gives us a lot more control anyway. And this is going to be important for our transferring of this function to a material, whether we do it as a custom output, which will probably do it automatically, or using the copy and paste, which is going to be the only option for View 5 and 6 users, which will basically just be removing that z-axis by changing the z to 0. You can see it did not change the node at all, but for a material, it is going to be really important. We'll see that a little later once we reach that point. So now we're not going to be using the terrain, Perl, and noise to create this. What we want is something that's going to work for creating the layout that we need. And we have a couple of different noises we can choose from. Like I said, we're using noises and not fractals because a fractal is just going to be too busy and too hard to work with. But we're still going to get a lot of detail out of the noise, provided it's used correctly. So we have the ability, we're going to be able to choose from the square samples. Under distributed patterns, we can just use the 2D one. We don't need 3D because we are working with just the X and Y. We don't need the Z, plus it's going to render everything a little quicker, process quicker. From square patterns, we can choose a variety of these to use, but I'm going to start with just squares. And then what I want to do is change the scale to 50. That's going to give me one square centered, provided you are using the object parametric mapping mode. If you're in a world mode, it may not match up correctly, depending on the position of the terrain and other certain factors. But this gives us a pretty good starting point. Now we're not going to stick with this shape. We are going to be clipping this out because there is a certain threshold limit on some noises that will cause spikes to show within the output, and we want to avoid those as much as we possibly can. So before we start modifying this, we are going to create a filter. So we're going to select the numeric link from altitude to squares, add in a filter node, and we're going to change this over to the smooth clip. What we want to get is a square with a slightly rounded top and possibly being able to round out the bottom a little. I'm going to set the contrast to 4. And you can see we have a nice transition on the top and the bottom. The more you increase that, the more of a steep slope we get. And you can start to increase the brightness in order to cut that out more. And taking a look at the node preview, we can see, it might be harder for you to see on my screen, but if you're doing this, you'll be able to see close up that we have a nice rounded transition from the bottom to the top. That's important for any time you're going to be using any sort of multiply blender or combiner node. But what I'm going to do is set the contrast to 4 and set up a bit of upper clipping and reduce the height to make it a little bit flatter. You can also set the brightness and turn it down to 0 to cut this out. Now, because we've clipped this, our normal output from a noise is -1 to 1, which is what we want to work with, but we're clipping it at 0, so our output is -1 to 0. So what we need to do is add in a map node. So we can select the numeric link, add in a filter, change this over to the map, and we're going to change first the output range to -1 to 1. So -1, 1 for our output range. Take the lower range and take the upper value and set that to 0. This will give us our correct output of -1 to 1. We are not going to clip the out of range values. We're going to keep it open because it's basically auto clipping for the most part. Another thing is if you're using version 7 and up, you can take this top connection, selecting all of these values, and create a meta node from the selection. And I'm going to call it vector transform, just to clean things up and condense them. Version 5 and 6 users, you'll just have to leave it within the function. It's really, if you're using version 5 or 6, you're not aware of what a meta node is. It's really just a container for nodes. So I can open this up, and we can see the function within. So that's all that really is. It's just going to make it a little bit easier to use or to copy and paste multiple nodes. So what we want to start doing is obviously adding more nodes in order to make this more interesting than a square. So I'm just going to move this up. What we can do is we're going to be using the same set of noise and filters, and we can select all of these, Control C to copy, and then selecting off of it, we can Control V to paste, or you can go up to the top, and with those selected, you can. It looks like the copy is grayed out, although the select and keyboard shortcuts do work, so I can paste them. So that might be version dependent. You'll have to take a look and see if that works. If not, you may need to rebuild that section, which of course it will duplicate values over if you select it and then create that same type of node. The advantage of the copy and paste is it will automatically connect our noises to that vector transform. So now we're going to take the output to the altitude, select that, and we're going to add in a combiner node, which we're going to set to combiner. Combiner is much nicer than the blender because it gives us the ability to input a very large amount of noises and nodes and functions to the same node and control a lot of different values. The disadvantage is none of these values, amplitude or the offset, can be extracted or controlled with other nodes. They do need to be inputted in manually. So that's the main difference between the blender and the combiner. They're really not any better than each other, it just depends on the situation. So now if we go ahead and add in or connect input 2 to the map, we can see input 2 showing up in the combiner. We also want to modify this other noise node. So we can reduce our scale and start to add what are basically going to be buildings. Go to the combiner. We're not necessarily going to use the add mode. If we switch over to the max, we can see what we're going to get is that large section in that first node, and then where it is reduced, the smaller square showing, and the minimum is going to fit the smaller node within the higher value. Now, we're going to need to avoid certain combinations of nodes in order to prevent spikes showing, and that's going to be caused by overlapping areas of small details. So right now there really isn't much happening. We don't see that with this setup, but if we go to the square noise and we start to offset the X a little bit, what's going to happen, and we can see this on the right side, is we have a very thin amount showing. and it is creating this very flat spike on top, and that is going to render terribly, be difficult to work with. Now, unless we create a very complex function that may not be necessary, by making sure that everything is always fit within certain box ranges, we're not really going to be able to avoid these on such a large scale. We will run into them, but most of them will be pretty small, and there are ways that we can avoid it just by using connections like the multiply in only certain situations. Another thing you'll want to avoid with this type of connection, and we're going to go back and just remove the origin for the moment. If you take a look at the ABS and ABS modes for variable roughness, max, and min, if we go over to the minimum, what you're going to see is an outline of the difference basically between the high and low points, and it is very spiky. Now, the geometry amount that we see within the output observer is pretty minimal, and it's not necessarily going to look like this when we render. But if you can really start to see some very jagged edges within the output observer, you're more than likely going to run into trouble once you start rendering. If I close that out and we take a look, it actually looks pretty good, at least in the center portion, where it is subtracting. But where it is adding to the selection, or adding to that inner noise, we can see those thin areas that just are not going to look good. So we just need to make sure that we're applying these in a way which it's going to give us a good clean function overall. Now in this case, we could really create another combiner, set it to the minimum, and go back to that first outer edge to cut out those areas. And now those outer sections are basically gone, with the exception to these very small sections on the inside, or the very edges, that do have a small spiky amount. But using certain combinations of things can really help remove some of those artifacts if you want to use some of those modes. Those modes can create very fine details that aren't always going to be needed and can cause problems. But if we take a look at some of the other modes, there are certain things we want to avoid because of the way they're going to intermingle and subtract within the areas. If we do a variable roughness, not only will it add in or change and mix these two noises, but in certain cases it will also create a bevel around the outer edge, which might not be a problem if it's going in, but this function is going to get reversed every once in a while once we start adding additional nodes and using different connections, and then we're going to run into those spiky areas, and certain overlaps are going to be somewhat unavoidable unless we spend more time, or a lot of time, really fine-tuning the origins of everything. And even then, it might not work well because you're just not going to have enough variation to make it look good. So it's a little restrictive, but for the most part, you can get away with a lot of these different connections. So we're going to start by using the min combination mode. I also want to note that we can modify offsets within the combiner. Basically, this is the same as if we were to add within that numeric line a filter of offset x plus a, and then you can offset the value. Now what this is doing is just raising it up. It's not adding anything to the actual numeric value. It is shifting it in one direction or the other. So if we have our normal value is -1 to 1, now we've offset it by 1, and you can see that our value is 0 to 2. So we've offset it by 1, brought it out of the negative. So that is built in to the combiner. I also want to note that the function node preview is going to show you the preview of your current selection. So if you have any filters or anything like that, if you want to know what the input is, especially if you're fine-tuning a map node, you'll need to go and select the link before the map in order to see what is going to be input into it. Because the node previews are just a really, really useful tool. So now we can vary this a little. We can start to modify and transform wavelengths. You can also see that we're running into some of those spikier areas. I'm going to go back and we can adjust the offset to get rid of some of those if needed. We can also adjust amplitudes, and you're going to start to see that it'll show different nodes and start to invert certain areas. And like I said, in order to get variation, some of the spikes are going to be unavoidable in these situations, but for the most part we can manage it. So we'll change the squares, the second one, to 6. And now we'll start to see more of a grid showing. So we want to continue by adding, selecting these, copying and pasting, duplicate. We can add this to the current combiner, modify our size, and then fine-tune the amplitude and offset in order to get the look we're hoping to achieve. Now we can see a lot more detail showing. We can set a little bit of an offset so you can move through. And that gives us a nice little variation. We can also start adding in additional combiners. So we can add in another combiner node. And let's go ahead and set this to the max combination mode. And add this to that second. And now we'll start to fill in some of those other areas. And we can fine-tune and kind of pull out what we want from it. And then continuing, copying and paste that over. I'm going to reset the origin and switch this over to a different noise. So some of the other ones available, square pairs doesn't really appear to show up in the version I'm using. It might be limited or just really not work within the terrain editor, which is possible. But there are different ones we can choose from. We just need to be careful of the edge amounts that we have. Now if you want to take a look at just one specific noise, you can take the altitude function and just connect it to that one output. Now if we take a look at the squares, the edge is really sharp. There is really no transition, even with the smooth clip turned on. So it will be difficult to control our materials that will be based on slope, and it's going to create more jagged lines within the function and the geometry output. So staying away from these random altitudes, unless it's filtered first. There are certain filters that will make it look a little better, but we have some other options that are a little bit better. Square stones is one that I like to use. You can see it gives a really neat variation. Some nice different sized squares that we can modify and kind of overlap with the other ones. So just adjust our scale here. And then if we take a look at the smooth clip and how we're cutting this out, we'll see the real look of the function. We can also choose to show this in the graph if we want to see how it is being clipped. Although these options, whether you're if you're showing it, may not always be remembered once you close out the terrain editor or the function editor. So let's go back and connect that to our other combiner. We can add in the new one. So now we have input 3 as the new option, and we can blend this how we need to, or we can set up a new blender or a new combiner to get a different variation. I'm going to disconnect that from this combiner, add in a new combiner underneath it, connect it, and that way we can change to a different mode. So if we select minimum, now we can see a little different variation showing. We also have some spiky areas starting to show up because of the size and interaction between the different noises. So it is difficult to keep it perfect while still keeping it interesting. So I'm going to go back to the square stones and make these a little bit larger. We can also go to the scale and zoom out if we want to take a look at more of the function. The scale can be reduced within the terrain editor after we close it out. If you want to say change that scale to 0.5, so half of what we currently have, you can do that within the terrain editor, or you can modify the vector by using a divide or multiply math node. So we can even go back and start to add in these other noises that are already set up, and using different minimum and maximum modes, or adding and multiplying, things like that. We can, while already having noises set up, they might be cut out within the current output or in different outputs, so you can get more variation that way. So let's go back to that first noise set that we have. We can copy and paste and add that in, and then we can add in another combiner and add that to our function. I'm going to reduce the scale to, let's go ahead and bring it down to 10 and set the Y to 2. And our combiner is going to carry over the values that we had from the previous combiner. So I'm going to reset that to the default. And we're going to change this to add. And we're going to start to add in more detail. So we can continue along and create smaller and smaller details to add in or subtract from this. But I'm going to go ahead and pause for the moment to take a chance or time to save this out so that I don't lose any information in case we run into any problems. Also gives me the ability to go back if needed, but we can see that you can just change that scale within the altitude production. And the preview options you have set within the function editor will change the preview you have for this procedural tab for the altitude production. So really quick, I'm going to go ahead and save. So I've gone ahead and saved this out as city function underscore 01. And if you're using versions 8.4 and higher, you will be able to load this scene in. If you're using a version 5, 6, or 7, 7.5, or even an earlier version of 8 that hasn't been updated to 8.4, you won't be able to load this in. If we take a look at the terrain, I do have the gizmos turned on for version, I believe, 6 users and up. If you're not using, or if you're using version 5, you don't have the gizmos, you can go over to the numerics tab to modify the scale or the size of the terrain on the z-axis, or up and down. I'm just going to size this directly. I've also got keyboard shortcuts set up on my mouse to switch between move, scale, and rotate really quickly. So you might see me switch over and not mention that I'm switching between the scaling or the move tools. So you can set up keyboard shortcuts yourself. If you want to modify these, it is in the order move, rotate, and scale. And you have both a global and local coordinate mode that are going to be useful for this. Otherwise, you can go into the numeric tab and manually set these options. I'm going to go ahead and move this up. And I'm going to go ahead and rescale this as well, because this is a very small terrain for this scene. It is going to be difficult to navigate. So let's go ahead and set it up to 256 meters by 256 meters. And then we will need to compensate for that scale on the Z and start to raise that up. Now, depending on the final output, the pivot position of the terrain will be in different places. Sometimes it'll be way under the terrain, sometimes it'll be above, depending on that final output. So before we go ahead and really finish up the function, I am going to make sure that I do have values between -1 and 1 in order to keep my pivot in a useful location. But we can scale this and now start to see that we've got some basic building blocks laid out. So I'm going to go ahead and just show you a quick render of what it looks like at the moment so you can see the geometry. Just setting it to a final render mode, rendering it to the screen, and we'll go ahead and make this full screen for my current setup here. So 1280 by 720. Set that to free user defined. And we'll take a look. Now once it's finished rendering, it's going to bounce me down to a windowed version of the render. But if you do want to see that full screen again, you can just close that out. And within the main camera view, you can select this little 3-color bar and display the last render. And this is showing the color of it. So you can see for the most part, it rendered really well. The anti-aliasing might need to be upped a little bit, or the quality of the procedural terrain increased, depending on any artifacts you're running into. But for the most part, it's looking pretty clean right now. It's going to be easy to work with, and now we can start to add additional details. And once we kind of have one of these set up, we can take a look at different material options for them, setting up different layouts, and really randomizing it, and even using the same function to create entirely different looks for everything. So there's a lot we can do with this, but this is a pretty good starting point.